Better get started. My name's Danny Pope. I work in the Brisbane office of Qt, and I'm one of the 4 members of the Qt 3D development team. So first up, better things that you could be doing today. All of these other much more interesting things are going on in different rooms. So they've got networking, we've got graphics performance, we've got doing stuff on Symbian, we've got publishing Qt apps, and C++ versus QML. So those things I think are much more exciting than being here. But the good news is, the stuff I'm going to cover today will actually give you a glimpse of pretty much all of those in practice. So hopefully by the end of this, you'll have seen a little bit of how all of those things fit together in Qt in a 3D context. So what am I actually talking about today? Firstly, it's going to be at a quite high level. My abstract was very abstract, and it was written before I'd actually written my presentation. So it didn't give an exact detail of what I'm going to be talking about. But in essence, what I'm going to be talking about is how we develop 3D applications, both as people who are experienced with 3D and as people who are newcomers to 3D. And basically, we're looking at lowering that barrier for entry to the 3D world, how we can add 3D content to our two-dimensional apps quickly and easily, and how we can make interesting real-world applications with 3D content in them. So it's going to be high level to start with, and I'm going to concentrate on a little bit of the philosophy behind Qt Quick 3D. And then I'll be delving into a few more of the technical details. Now, as far as technical details go, my colleague Sarah Smith is presenting another Qt Quick 3D session immediately after this in one of the other rooms. And she's going to be going into much more sort of low-level, diving down right into the depths of it, how you get vertices uploaded to the GPU, textures, management, that sort of thing. So I'm going to start out with the basics, getting up and running, what Qt Quick 3D currently does, and then mine will hopefully complement what you might see in hers if you're going to go for it. So I'd really recommend, if you are interested in 3D, going to her session immediately afterwards. So what's ahead? First up, I'm going to be talking about who we're aiming Qt Quick 3D at. Now, I'm almost guaranteed to trip over that before the end of the day. So who are we talking about when we're looking at Qt 3D? Who are the usual suspects? Who's interested in Qt 3D from a development perspective? Who this changing paradigm of development refers to? I'll then be discussing what we can do about it. What's the solution which offers people this ability to do 3D stuff easily? And the answer to that is obviously going to be Qt Quick 3D, because, you know, that's what we make. Now, as part of that, we're going to be discussing what Qt Quick 3D currently does, its latest features, what's happening with QML2 integration, and we'll also be going off into all sorts of weird tangents about 1970s fashion, artificial intelligence, the Apollo program, all sorts of stuff. Should be fun. After that, I'll do a quick example that will prove, conclusively, I hope, that within about 20 minutes, you can put together an incredibly contrived, yet hopefully convincing 3D application which will, show the capabilities that we've currently got there, at least in a small degree. And finally, we're going to be jumping forward into the future. We're going to be looking where Qt 3D is going. And you might notice, by the way, that I'm using the terms Qt 3D and Qt Quick 3D quite interchangeably. The official changeover of name was quite recent, so I always think of it as Qt 3D. And I actually naturally have a list. And Qt Quick 3D, it just makes all the S's in my sentences turn to which is not good. You don't want that. So yes, we'll be looking at the future, and particularly how you can influence that future of Qt Quick 3D. And that's really important, because we really do rely on external input. So, who is Qt Quick 3D aimed at? Who are we talking about? Well, there are a lot of people involved in 3D applications. There's people with commercial interests, there's the users, there's all sorts of people, but the people we're most interested in are design people and coders. Who here is a coder, mostly? Who has more design sort of background? Excellent. You, sir, come to this presentation for me. So for most of you, so you've all done 3D stuff before too, I assume? A lot of 3D, a little bit of 3D. And you all think 3D just with straight OpenGL is super easy? Making a user interface, that sort of thing? Well, you might. If so, also assist this gentleman in doing the presentation. So yes. Now, so it's a versus match. It's coders versus designers. And in the bad old days, that's how it actually used to be. When I first started out developing user interfaces and things, designers and developers were worlds apart in the way they thought. And it really was the bad old days. So the designers would have these great, creative, wonderful ideas of what they wanted. And they'd go over to the coders and say, quick, make me this. This will look awesome. And the coders would scratch their head and complain and bitch about the designers a little. And then they'd go off and make the best thing that they could, which was as best as they could what the designer wanted. But the two groups think in very different ways. And often you come out with things which weren't quite optimal. And there's a very good reason for that. They do think in very different ways. The designers come from a much more high-level point of view. Coders are, well, a lot of coders are really interested in the actual low-level functioning of the code itself. And a really good example of this is Windows Mobile. I was once a Windows Mobile user, I admit. And I really love my Windows Mobile device. Did anyone else use Windows Mobile, by the way? And didn't like it, exactly. Because the user interface was less than stellar. There were some good ideas that they tried to implement, but the hardware just couldn't support it. That's not to say that it was a bad platform necessarily, and Windows Phone, the latest iteration, has obviously completely fixed all of those problems, and it's a really enjoyable experience. And that really highlights the difference between old school thinking and the new school of thinking. So just to summarize, you've got the designers who are using a lot of high-level tools. They're interested in the look and the feel of the application, how we interact with it, how we can make it better for humans to interact with it, whereas the coders worrying more about what the platform can actually do, what the strict requirements are that they need to fulfill, and the actual code itself. So there's that lost in translation effect that you're going to get between the two. Now, thankfully, that's a long time ago that happened, and the two groups are getting closer and closer together. So ultimately, what we want is to bridge this divide. And there are challenges in bridging this divide 100%. Now, I've stolen this slide wholesale from our marketing people. But it's really relevant to 3D, particularly accelerated hardware. What does accelerated hardware mean to a designer? Well, get a designer to go write an app in OpenGL ES 2.0. It's not going to happen in any sensible way. Got to write some shaders, got to do all sorts of crazy stuff. It's hard. Thinking in 3D is hard. I still find it hard. It's not much fun. And then on the other side of things, we've got user experience. Well, what does user experience mean as far as code goes? How does the code itself translate to user experience? How do we keep up and rapidly prototype and actually keep up with the changing market for user experience? And that's really a hard question for a coder. How are we going to implement that so that we can go backwards and forwards between the designer and create the best user experience for our customers? And that's kind of the third point down in the bottom left-hand corner there. The cooperation between designers and developers. What we need is a common space which they can work in, and one which is also portable, or at least portable across a lot of platforms, with minimal changes. And so that's basically the who and the challenges that we've got. So what's our solution? Well, of course, it's Qt Quick 3D. And we do think that for the 3D space, it's a really good answer for bringing developers and designers together and for lowering the entry barrier to people who are new to 3D. I might just want to make some 3D buttons in my application. I don't want to have to go out and learn how to write a shader to put a button on my screen. I want to just be able to say, put a button over there. And that's what Qt 3D is aimed at doing. So now that I've told you that, it's time for a brief history lesson. Nobody's actually spoken about the history of Qt Quick 3D before, as far as I know. So this will be a new experience for all of you, me included. So once upon a time, there was a developer with a very large brain and nothing to do. He'd just finished the Qtopia project, and he was looking around at what his colleagues were doing. They were running off doing QML stuff and multimedia stuff, a little bit of other mobility stuff, and he thought, what's missing here? And the obvious thing to him that was missing was 3D, probably because he was just interested in it at the time. But it turned out to be a really good idea. So he kicked off with just making a direct set of Qt-like bindings to OpenGL. His idea was, well, you know, Qt's easy to use, so let's make OpenGL more Qt-like. And that was good. But it rapidly became clear that you could do a lot more than that. And a team came together and they started to put little bits on and add little bits and pieces until there was a relatively small yet quite powerful framework for developing Qt applications which had 3D content. The repository went public in early 2010, or very late in 2009, I think, and that's when we began to get input from the community, some of it positive and some of it negative, which was really good, because whether it was positive input or negative input, it allowed us to figure out where we were going to go next. And it was that feedback from the community which enabled us to go ahead with our first technical preview in mid-2011. So about halfway through this year, we decided that we'd actually release a version of Qt 3D which had installable binaries for people who wanted to get up and running quickly. Now, we targeted a few platforms with that. We attempted to do Symbian. Didn't work very well. Mamo was good. Windows, but only for those people who were using Microsoft Visual Studio. And I think there were some Linux packages in there as well. The idea of that was to get people who wouldn't normally be using Qt Quick 3D to give it a test run. And a lot of the time, that's people who aren't necessarily wanting to build it from source. They want to quickly put something on, test it out, write some QML, see what happens. And we learned a lot from that. So the following 6 months were a feverish period of fixing bugs and adding new features and getting a dialogue going with a certain number of members of our community who went on to contribute a lot of stuff to us. And that's basically where we came out with TP2, or Technical Preview 2, which was just a few weeks ago. And it worked perfectly well on Symbian now. We'd fixed all the problems. And everything was going great. Now, as part of the course here, at some point we said, you know what? The QML stuff is really the future of 3D. That's what's going to make 3D easy. We were going to migrate towards QML for a bunch of good reasons. And again, another stolen slide from some marketing people, but much more relevant to 3D. It's easy to learn Qt Quick 3D because it's a language which is tractable to both designers and coders alike. It's very straightforward. It describes what is going to be there. It creates that dialogue between developers and designers. And from my point of view, coming from both a code and a human factors background, this is a major thing. It's quick to iterate. We can go backwards and forwards between the designer and the developer super quick. It's quick to render, and this has a number of meanings. First of all, obviously, because there's no compile step required, it's quick to just get it up. There's a bunch of things in there for reading 3D models already and optimizing the display of those. It's not necessarily quick to render as quick to render as a C++ version of the application. And if anyone of you attended Bee's talk on Qt Quick changes yesterday, she's sitting down the front there, stick your hand up, Bee. You would have seen that rendering in QML version 1 is literally walking up a tree and rendering all the items individually. Now, while individual items might be optimized for rendering, it's not necessarily the case for the entire picture. And it's quick to extend, which is one of the most important things. You can easily create your own little bits of OpenGL that you want to throw in, or shaders that you want to shove in there, because of the plugin architecture of the whole thing. And this is really important. I could literally take away all of your ability to create a C++ executable and just give you QML, yet you would still be able to do all of the same things because of this plugin capability. And that's kind of cool. So those are the marketing reasons. But is there any hard science to say that this is actually the case, that QML is better? And this is where we sort of go off on my little random tangent. It's the 1970s. Good fun. Beverly Hillbillies has just been cancelled on TV, early 1970s here. Apollo program's coming to a close. We've got, massive platform shoes, which would make me about this tall. It's good times. It's a time of change. Disco's on the horizon. How good is that? But nowhere is the change more significant than in the world of artificial intelligence. Well, from my point of view anyway. Up until this point, artificial intelligence is really strictly logical. It's, a procedure. Here are the steps in thinking. It was clean, it was concise, and to be quite short, it was neat. There were a bunch of other researchers, though, who said, you know what? I ain't cool with that. I don't think that's how it works. And they immediately knew it was the wrong approach. Actually, they didn't immediately knew. What they did is a whole bunch of research, and then they decided after that research it was the wrong approach. Because it turns out that humans don't think about the world logically or procedurally. What we do instead is think of the world in a haphazard, loosely hierarchical structure of things around us. So you've got these two opposing factions, the neat people and the scruffy people. Now, in 1975, a guy called Marvin Minsky came up with an idea called frames. You probably remember this from computer science. Does anyone remember it from computer science? No? Oh, God. Yes, frames. So what are frames? Well, they're a way of describing the world in, funnily enough, a declarative way. What you describe is, for example, if I'm in this room, I describe it's a room, it contains chairs, the chairs are arranged just so, the chairs interact in this way with the people who sit on them, and these sorts of things. And you will all have actually encountered frames in one form or another because you used C++. And that's where the idea of inheritance came from, object-oriented programming. It was directly taken from this research. Roger Schank extended this idea with the idea of scripts by saying, okay, we've got frames, let's add fragments of procedural knowledge, not actual full procedural knowledge, that describe how things interact in a slightly procedural way between things. It's kind of a little short story of what happens from one point to another. And it turns out this is how humans think. We don't have programs in our head, unless we're serious coders. What we've got is these hierarchical semantic frameworks which are augmented with script-like knowledge about things. And that's where we are today. So in short, without anyone realizing it, what we've actually done is taken 3D and pushed it right back to the 1970s. Awesome. So I've thrown this slide in because I actually got at least 2 people ask me so far whether we're going to actually be doing any 3D stuff in QML2 without even realizing there was such a thing as Qt Quick 3D. So there you go. There's our summary, our Batman and Robin of Qt 3D. We've got, Batman on the left-hand side. He drives the Batmobile. He's got the gadgets. He's got the low-level knowledge. Does all the cool stuff. And then on the Quick 3D side, that's Robin. It's newer. It's quicker. It describes what's going on. It's kind of cool. Kind of. Yeah, that's really breaking down. So now we'll actually get into what's gone into the most recent version of Qt Quick 3D. First of all, we support multiple platforms at last. So we're across the N9, we're across Symbian, Windows, Mac, Linux. We've got all of our main platforms covered as we currently stand. We now have network support for downloading of assets. Now, when I talk about assets, I'm talking about either images, which are then used as textures, or I'm talking about 3D models themselves. 3D models are traditionally hard things to do. If you've ever used something like Blender or Max or something like that, you know that it's not easy to generate a 3D model. And 90% of the time, what you actually want to do is just buy a model and download it, keep it stored somewhere in the cloud, grab it when you need to. Grab a texture. I might want to put Flickr photos on a photo gallery, which you might see a little bit of later on. And that's what we're talking about by the network downloading assets. And that's all invisible. So now you can just create a URL or put a URL in as the source of our texture, for example, or the source of our 3D mesh, and magic will happen in the background. Now, there are a few caveats to that, and I'll actually go through those with you later. So we've got inline shader support, and I added this yesterday because QML2 have been jumping up and down and shouting about how they've got shaders. We did it first. You can put shaders directly into your QML application for 3D effects, and I may be even able to demonstrate that. So there we've got a vertex shader which is actually collapsing a mesh into a simple quad. And conversely, we can animate the texture coordinates in our shader. So what we're actually doing is creating properties in QML, and I assume you're all relatively familiar with QML to one degree or another. We're creating properties in QML, importing those directly into our shaders, just as you can see in QML2. So we're changing scale factors, and we're changing texture coordinates in this example. And you'll see another little shader example later on when I compare and contrast. Actually, in fact, I might just show you that now. So another simple shader example. You can see the sun in the middle of our solar system there, and there's a shader there, a fragment shader, which is just going from one texture to another to give it kind of a glowy sun effect. And obviously, these are very simple examples. Shaders can do a lot more exciting stuff than that. You can do all of the stuff that you would expect to see from shaders in QML2, wobbly, cool, wavy effects like B did simply yesterday. All sorts of stuff, and it's very cool. But enough of that, on with the show. If I can get it together. What else have we got? Dynamic object creation. At last, we can use all of the repeaters and list models and stuff. This was a major complaint when we did our first technical preview. People were like, I want to create a game with 3D stuff where spaceships appear and I want to blow them up. But we couldn't do that. Well, we could, but it was really, really bad and inefficient. It's much more efficient now. I'm going to be doing a bit of dynamic object creation when I do a little bit of a coding demo in a second. And QML2 support. Now, this is our sort of big feature that we've spent a lot of time working on. QML2 has been a really fast-moving target for us, and we've constantly had to change to keep up. And because of that, we've had to make a number of adjustments at a technical level as to how you can use 3D content in a QML application. Now, I'm sure you're all aware that QML2 has its own special magic scene graph. I'm not going to call that a scene graph because in my terms, a scene graph is a 3D semantic thing, a structure of a 3D scene. So in order to fit into the QML2 not scene graph, what we've had to do is make a few compromises. So you've got two options. You can either have the 3D content underneath all of your QML stuff. So you can have QML controls and buttons floating on top of your 3D scene. And that's the most efficient one. So basically, you've got a full screen app with a bunch of 3D stuff in the background and buttons on top. So you might have a simulator where you've got a full 3D scene there with a cockpit and everything, and then you've got some just actual controls that people can touch, which are just regular QML2, which sit on top of it. Sorry, I'm actually losing my voice today, so do forgive me if I'm sounding rather more and more croaky as the day progresses. Once you start asking me questions, I'll go completely mute. And the other option is to insert a 3D layer in between. The way QML2 works, as you know, is grabbing things, compositing them all together, optimizing it. Now, because we can't therefore grab the OpenGL context because it's already doing it, and it's threaded, which makes it even harder because you don't know whether the context you're using is currently in your thread or you can grab it or can't grab it. What we've had to do is make a compromise if you want to have some QML underneath and then a layer of 3D and then some more QML 2D on top. So what we actually do in that case is render to an FBO, so render to a frame buffer, an off-screen buffer, and that allows us to render to that buffer, insert that into the QML2 scene graph, and then that will be rendered as per the rest of it. Now, obviously, there is an efficiency issue there, and that's why we've got this GL under case where we want our GL underneath everything else, which is highly efficient. But there are some benefits to doing this FBO rendering as well, because now we've got a scene rendered to an FBO, we can then use that as a texture on other 3D stuff. So I could have a 3D scene placed on another 3D scene as a texture. So I might have a cube with a cube view on the side of that. And we do have an example of that also. Now this one's implemented in C++, but it's doing exactly the kind of thing that I'm talking about here. So you've got a 3D teapot rendered on one of the cubes, and then that's added into a 3D scene itself. which is a kind of cool thing to be able to do. It allows you to do a lot more than that, and I'll discuss that when it comes to future directions of Q3D shortly. Time's running kind of short because we did start very late. So I'll try and get through as quick as I can. So a quick example. And hopefully this example will demonstrate how easy it is to do something in Quick 3D and give you an idea of simple capabilities that we can use. So yeah, we'll go with this one. It's not working out so well. So here's our use case. We want to create a three-dimensional photo gallery. The one I'm creating won't look quite as complicated as that because I don't have the time. We want to be able to destroy photos from this gallery, which have been downloaded from, say, Facebook or Flickr or something like that. So we want to be able to destroy them, get rid of those objects off the screen, and when we get rid of one, we want to create an entire new photograph on a quad and drop it into the scene smoothly. So that's what I'm going to try and do right now. So, is that good size for everyone, by the way? People at the back? Excellent, brilliant. Right. If you'll bear with me for 1 second. I forgot to clear out the finished version. Okay. Let's just give that a try. So what we're going to start with is not that. The perils of live coding. Stupid thing. I think I know what I've done. I've just rebuilt. I'm rebuilding this because it's actually built as a standalone executable application. So we actually want to futz around with some of the things in there. It actually has to copy all the stuff across, so. There we go. We're meant to be starting off with just a cube. This is actually one of the demos, which is just part of the Quick 3D. Basically what we've got is a built-in skybox, which you can use for the background of your applications. I've just dropped a cube into the picture there to demonstrate that you can just drop 3D content in. And I'll just double check that I'm editing the right file. I do apologize for this. I was hoping to avoid doing the compilation step every time. Yeah. I've got the wrong file open. So now I'm editing the right file. Excellent. We can continue. Everyone relax. Okay. So we've started off with a cube floating around in 3D space. So let's have a quick look at the code for that. We've got a big QML rectangle, which acts as our background. We've got a 3D viewport. So you just call it a viewport. We've thrown in a camera. Now I've done some fancy maths for the eye position of the camera, where that camera is sitting in space. It's not really fancy maths. It's just basic trigonometry for a unit circle. So it's just rotating around. Which is why that cube is rotating. Alternatively, I could have just rotated the cube, but then the skybox would be sitting still in the background, so it wouldn't really be a good effect. So there's the animation. It's a standard animation from QML. That's a skybox. That's how easy it is. You just say skybox, source, skybox. what that source is describing is just a directory where all the images are. And there's our cube, and it's going to be that color. So pretty straightforward. So the first thing I'm going to do is change that cube into a quad. There we go. Not exactly rocket science, and not exactly what we're looking for in the end. So the first thing I'm going to do after that is to add some rotation to that quad, so at least it's sitting around the side so that once it comes around we can actually see a photo that we're going to put on it. So I'll go to my quad, and I'll give the quad an ID of item so that I can do stuff with it later on, and I'm going to add some transforms. Now, you are still going to have to know some math to make your way in the world of 3D regardless. Abstracting it all the way would be delightful, but also impossible. So we'll add in a... Damn, I'm glad I wrote all this down somewhere. Got that idea from you. So we're going to flip it 90 degrees, and we're going to do that on a couple of axes. So that's going to be on the y-axis. So we've got that 0, 1, 0. That's, if it was x, that would be 1, y, and z. And
I think you need to close your rotation 3.
Will do. Roger that. And we're going to flip it on another axis, 270, so I'm going to flip. Now, fortunately, I know which angles I need to flip this on. It can take some trial and error, unless you're well into the 3D space already. So wow, what happened there? Oh, I know, because I haven't. Yeah. I'm with you. So that's much better. It's now kind of something that we could see if there was a photo on it. So the next thing I'm going to do is create a bunch of those. And to do that, I use the standard list model stuff that you would see in QML, which makes it easy. So I want to have a list model. Oops. With an ID of dynamic model. And I want to have, we'll start off with one list element, which will be our quad. And that's x2, y2, 0, z. How are we going for time? Yeah, we're pretty much almost out. Do a late start, so I'm going to have to accelerate this a bit. And we create a component with an ID of quad delegate, because we're making a delegate for 3D object creation here, just as you would in QML, and we're adding a quad item to that. And we'll add its x as model, y as model, y, and z as model.z. Okay, and hopefully most of that will be sufficient. I just need to add a repeater in my viewport, which is the thing that actually creates the multiple instances. And again, those of you familiar with QML will already be familiar with this sort of stuff. And the delegate is dynamic quad delegate, and the model is dynamic model. So, fingers crossed, because I'm rushing it, that'll work. Yeah, there it is. It's still working. So it doesn't look like it's changed at all, but in actual fact, it's dynamically created that item. So we'll skip ahead a little, because we're really running short on time now, and I would like to allow at least some time for questions. I'm just going to change the color. So I've got some alpha ability so I can fade it in and out later on. We want some blending to go on later on.
You heat missed an E.
Yep. Yep. And we want to decal it. And we want the texture to be... Now I'm going to skip a section here because I don't have time to do it. What I'm going to do is
you should probably have a 3 in that.
much better. Fortunately, I have my trusty assistants here. I've planted them throughout the audience to ask really good questions later too. So I've got a function there which grabs the next image from wherever it may come from. And hopefully, because I've skipped a whole bunch of stuff, that will actually work. There we go. What it's done is downloaded an image. Now it's upside down at the moment. We can add a transform later on to fix that up. I'm not going to bother right now. The reason for that is the changing coordinate system, basically. So that's actually fixed in QML2. QML2 now has things the right way up. Now, I've just been told that I only have 10 minutes to go, so I'm totally running out of time. So what I'm actually going to do now is just start grabbing stuff wholesale from out of the final version. I'm going to make an animation in there, which is just a combination of animations. Pause, and then it changes the color of the object to be something we can see. It changes the alpha, which you can't see on there. So you can see it's just changing the color to an alpha value of 1. So I'll have to change the other alpha to 0. And then number animation to drop into the scene. So I'm just going to grab that straight out of there. And drop it into my quad. It's really hard coding with text this big. Note for all of you who are going to do presentations one day on this stuff, or anything. So, yeah, that doesn't work, does it? What have I forgotten?
You haven't started that.
The animation should start on its own. Yeah, running is true, duration 1,000. Yeah, I know what I've done. Obviously, to drop it into the scene, I've got to actually, drop it from somewhere. And 111. 200. Let's try that.
Did you have an ID on the effect?
I'm sure I did. Did I not put that in? Let's see. I'm so glad you're here, man. There we go. Photos drop in from the top. Now I'm going to skip the rest of this because this is just going to take another 10 minutes and I don't want to take up your time for asking questions. So what I'm going to just do is grab the final thing, and all I've done in here is added another animation to destroy the object, exactly the same as the first one. I just added a remove from the list, and I've changed the background image to look nicer. So so much for all my preparation. There we go. So now we've got, wow, that comes up really badly big in this resolution. So it drops pictures in, I click on them, they drop away and fade, and new ones drop in, which they're downloading. Now, I only took 10 minutes to do the first half of that. I promise it was only 10 more minutes to do the rest of it. I guarantee it. And if anyone wants the source code for that, it's actually in the Qt3D repo. I do apologize for the fact that this couldn't finish, but there you go. So I'll quickly get on to the final bits of the presentation, then give you some time for questions, because I'm sure some of you have them. So our future wish list, we'd love it to have all of these great features. We'd love it to be mature and stable, lots of tooling, designer friendly. But we've got to pick from these. And here are the things that we are currently actually working on. Complex effects. Now, this is where we were talking about with FBOs before. FBOs allow you to do more than just insert something into QML2. What they allow you to do is a whole bunch of multipass sort of rendering effects, glows, blurs. You can do reflections. You can use them to do shadow effects once you've done the right other stuff to go with it. We've actually got people in the community who have already submitted some code for this. And we're writing additional code ourselves. But it's a really important thing to have, both from the point of view of QML2 and a point of view of really good applications. The other thing is Qt Creator integration. Now, at the moment, it integrates as far as code completion and that sort of stuff. It's not enough to just have that. When I'm designing an app using Designer, I want to be able to put a 3D viewport in, drop some items in that I know I'm going to be able to use in there. And that would have been really useful during this presentation, rather than having to type all that stuff. I could have just said, oh, I want to drop in this quad, drop in this, and that sort of stuff. Not necessarily place it in like a full 3D view or anything like that, but just drop it in so the code is there as part of a framework. And of course, beyond that is actual 3D model editing. Now, we're not talking to anything to the extent of Blender or Max, but what we are talking about is when you get a model from someone else online, there's no fixed coordinate system that they like to use. There's no up direction they necessarily like to use. There's no fixed scale that things come at. And you always, as soon as you get a model, you look at it, compare it to everything else, and have to scale it and rotate it and things like that. It would be nice to be able to have something in Creator which just allows you to go, oh yes, I want to just quickly align it, scale it, so it fits in the rest of my scene. So that's something that we're actively working out on right now, and hopefully will be in the next iteration of Qt Quick 3D within a month. So that should be good. Path animations are good. B did speak about path animations in QML for 2D cases, so you get objects moving around paths, but it becomes even cooler once you apply path animation to a 3D use case. Because I can now animate my camera along a path, so I could have a 3D fly-through of a scene where my camera is flying through an entire 3D scene. It might be a pilot's eye view of a stunt plane or something like that, which could be kind of cool. Enhanced scene hierarchy and rendering. Now, I did mention earlier that there are some inefficiencies in QML for rendering of 3D scenes, and this is part of that. At the moment, when you load a model, it gets optimized for display, but an entire 3D QML scene isn't optimized. What we want to be able to do is load an arbitrary model, use it as a resource library, pull it apart, reconstruct an entire actual 3D scene graph, optimize that, and then display it. And so you'd only need to actively change that scene graph if there was a major change as far as the structure of it, which would be very unusual, because mostly you're just adding transforms rather than modifying the actual structure of the scene graph. And that's a QML2 thing. We're going to have, so you've got the QML2 scene graph, which optimizes your 2D scene, and we'll have the QML 3D scene graph, which will optimize your entire 3D scene. So you'll be directly manipulating that scene graph in QML. Physics, which is something that's always cool. Everyone loves physics. If you want to do some really good games. For example, if I wanted a game or an app where I'm throwing some dice, hey, I've got that app on Android. It's really cool. I need physics. I can do it right now with C++, with the Quick 3D C++ part, but I can't do it in QML because QML, as it currently stands, doesn't lend itself to physics. So what we're doing at the moment is integrating the Bullet physics engine into it. As I've said, we've already done it we've done a bunch of use cases for that in the C++ side of things. Now we're going to QML. And the final one is the skeletal animations. We want more than just your simple animations that you get from QML, those sort of sequential animations on numbers and things like that to just bounce stuff around. We want to be able to compose entire 3D scenes with skeletal animation, which will then modify the mesh, blend two animations together, so you might have someone walking and waving, which are two separate animations, and that will allow you to do all of the sort of things you want to do for simple games, pretty much every 3D use case we've come across. Now, one of the other teams in Nokia actually did a bunch of this already with QML, and we've also got community members who have submitted some code, which is really great. So of all of the things I've talked about, and there's a bunch of stuff, all of those are things that are up for grabs. Now, we're only 4 team members, and what we rely on is members of the community to tell us what they want, and even to assist with creating some of those things. And as it's becoming more open governance, things like that, more and more it's important for the members of the community to start helping with that. So what we would value is if you're a coder and you've done some cool stuff, even if it's just like a cool demo, we would love to see it because that's what gives us the ideas of where to go next. If you want to submit code, we would absolutely love that. That would be absolutely fantastic because, 4 people can only do so much, particularly when you're dealing with a bunch of devices that you have to keep it working on and all this sort of stuff. And more than anything else, we want commentary from you. We want you to say, yes, this is the thing we want first. I want physics first. I want animations first. I want path animations. So that's the sort of thing we're looking for, and so we're really looking for you to contribute. So that's given you a basic idea of the roadmap for Qt Quick 3D and some of the little technical details. As I said, Sarah Smith, much more technical detail of vertex buffers and all sorts of crazy stuff in one of the other rooms in just a few minutes, in about 10 minutes, 15 minutes. But I hope you enjoyed the presentation. I do apologize for having to skip the coding part. That was the main part. So, but yes, thank you for coming. If there's any questions, now's the time. Otherwise, enjoy the rest of the conference.
You talked about integrating the 2D and 3D stuff. Can you give a short example how that looks in the QML code?
As far as the QML code goes, it doesn't look noticeably different from what we've got now. Basically, it's all under the bonnet stuff. It's hidden away from you. So you saw that example where I had a rectangle and then a viewport in it, and then stuff within that viewport. That would be the case of inserting the frame buffer into the QML scene. There's no additional stuff you have to put in to tell it to do that. It just knows I've got a QML object above me. I should be rendering this to a frame buffer and inserting it into the scene. If I'd had the viewport at the top level, it would have automatically done that GL under case, which is the optimized case. So there's no change to the QML at this stage. It looks exactly the same.
My question would be that whether there is some 3D particle system in progress or something like that for games, for example.
Not as yet. Particle systems is something which nobody from the community has actually asked for. So you're the first. If you do want to say something like that, send us an email. There's a mailing list for Qt 3D, or you can put it onto the public Jira database and let us know about it, because the more people vote for something or the more they hassle us about something, the more we're likely to do it. Now, so far we've spent a lot of time cleaning up all of the APIs. And it's only now we're getting to do the cool stuff, the physics, the particle systems, the high-level animations, all the good stuff. So we want to know what you guys want first. So please let us know. Come on, B, ask your complicated question.
Why doesn't it run on Windows?
It runs perfectly on Windows. Unlike QML2.
How can I add lights? So this OpenGL lights.
At the moment, there is a data structure in the QML for lights, but it's currently not working as it should, and it's been logged as a bug. Martin Tasker, who's actually just sitting up in the back there somewhere, sent a bug about this about a week ago. And Julian Debal, who's one of our designers, he's the shader guy, he's actually refining the entire lights thing right now. At the moment, it only supports one light because of some optimizations for OpenGL ES2, but we're having multiple lights in upcoming versions. And basically, you say, in that viewport, you say, I want lights at given positions, and then you can animate those lights just as if they're items. One other thing that, sorry.
So you're giving, the full power of OpenGL
Absolutely.
to the user. Mm-hmm.
Totally. We want to make it easy to use everything. We want to make everything that you can do in OpenGL just an object that you can animate around and do cool stuff with. I did get another question, which is quite relevant, the other day about how I can use my own OpenGL within QML. And if I can just take a very brief moment to look at that. So we've created our own, it really doesn't show up well in this big thing. We've created our own shapes library, which has, simple shapes, cubes, spheres, capsule things, points, lines. And it's a plugin. It's just an import. You go import q3d.shapes. Using that as a template, you can create your own OpenGL stuff, and you can basically just take this code, rip the draw function out of it and the creation functions out of it. And so here's the draw item for a point. Now we're using some Qt 3D C++ stuff to get this done. So we're adding some vertex array, we're adding a bunch of stuff, setting it to draw points. You could just throw your own OpenGL in there, whatever OpenGL you have, and then use it as your own import library. So it's that easy. If you want to do something with OpenGL, you've got a specialized set of OpenGL stuff, you can do it. So that was one of the questions I got wandering around. So that's all the questions. The next session's about to start, and I don't want to delay it. So thank you all for coming, and I do hope you've enjoyed it and enjoy the rest of the conference. Thank you.